just want to look at something back on that. Just think. Yeah, that's what it is. Okay. Yeah, for what I'm about to write down, we'll let we're gonna let A11 equal to A22 equal to KE. And so then K, the element stiffness matrix that we just solved for would be KE over 2AB times B squared plus A squared minus B squared. We didn't solve for F to show what it would be, but again, if you had a constant F, FC, then that would be AB over 6 times 1, 1, 1. So remember, this was for a node numbering scheme 1, 2, 3. However, if we had a different node numbering scheme, one, two, three, again with this side length A, this side length B, then we would have a different element stiffness matrix, KE over 2AB B squared. This will be the same. So, I don't know if you can tell, but basically by, this has the same terms in it as that up there, but they're just in different places, right? And it just, so essentially, if you wanted to, for example, start with that one and get this one because you changed the node numbering scheme, you would basically just have to transpose the swap, swap the rows and columns according to the node numbers, right? So basically, you would swap for, if you started with that one, you would swap the first row and first column for the third one, and then you would swap the second row, second column for the first one. Or I think you go the other way, right? So if you would, well, either way I think it works, right? If you want, so you would, I think the way I said it first is right. You would want to swap the first row, first column for the third one, second row, second column for the first one, third row, third column for the second one. And then you would end up with this type of formulation. So basically from any of those, you can get the others. As long as, again, we're just talking about specialized to a right-hand triangle here. But basically, if you had 1, 2, 3, three, 1, 2, or 1, 3, 2, 1, 2, 3. All of those scenarios would correspond to this stiffness matrix formulation. And if you had 2, 1, 3, those would correspond to this one. Huh?
They correspond to the same one? They could,
I think that's right.
unless the left one is
What do you mean?
the triangle on the left,
This one?
the public.
This one?
Yeah. So this one doesn't match the other triangle.
I mean, this one doesn't look like any of those, right?
Yeah.
Yeah. I think again, assuming that I didn't write it on there, but this is A and that's B on all of those. Yeah, I think if you worked it out, then all of these would correspond to that one and all of them. Okay, I guess we better stop there. So next time we'll just have a little bit to say about, since we kind of went into a lot of detail about triangles, I'll say a little bit more about rectangles, and then we'll talk about how to assemble the elements. And then that's pretty much all we need for scalar 2D problems. And then we'll talk about elasticity.